Resonance. What is resonance? Resonance is a phenomena where we draw multiple structures for a molecule which we are not able to understand through single Lewis structure. So, what we do is we draw multiple Lewis structures through our imaginations to understand different properties of that molecule. So, I will explain it through an example. For example, this is benzene. So, this is the structure which is actual structure of benzene. But what is happening is the structure of benzene is such that we observe there is partial double bond. So, we are not able to understand how to understand these properties of a structure which has partial double bond. So, what we do is we draw structures which are very near to this through our imagination. So, these are theoretical structures of benzene which we draw through our imagination. These are called as resonating structures or canonical structures. So, resonating structures are basically theoretical structures which we draw, theoretical or imaginary structures which we draw to understand all properties of a molecule which we are not able to understand through single structure. For example, benzene we are not able to understand because it has partial double bond. So, what we draw is we draw these possible structures through our understanding, and these possible or imaginary structures are called as resonating structures or canonical structures, and the actual benzene structure is this one, and this is known as resonance hybrid structure. So, wherever we have a molecule whose properties we are not able to understand completely through single structures, we draw multiple structures to understand its properties. So, these multiple structures, imaginary and not real structures, are called resonating structures or canonical structures or contributing structures, and the actual molecule is basically a contribution of those structures, which is called as resonance hybrid. Real structure resonance hybrid, and its imaginary structures are resonating structures or canonical structures. So, where do we have this phenomena? And overall this phenomena is called resonance. So, where do we have this resonance phenomena? For that we have certain set of rules which we follow, then we can identify. So, let us come to the slide or the page where we are trying to understand. So, what we have over here is that if you have conjugation, what type of conjugation? If in a molecule or ion you see something like this, double bond, single bond, and on this atom you find a lone pair, or you have a double bonded two atoms and the third atom has plus, or double bonded atoms and third atom has minus, or you have double bonded two atoms and third atom has lone pair we have done. So, we have free radical, or we have this system double, single and double. So, these are few structures where you can have something like this, you have plus and as representation of a lone pair. So, these are few structures which could help you understand whether resonance is there or not. If you find any of these represent conjugation in a molecule. So, if you have a conjugated system, what? Double single plus, double single minus, double single free radical, double single lone pair, double single double, or lone pair adjacent to positive carbon, then these are signs that resonance is present over there. So, wherever any of these is present, any of these, I am not saying everything will be present, I am saying any of these, double single lone pair, double single plus, double single minus, double single free radical, double single double, plus single lone pair. So, any of these is present, that means conjugated system we have. If conjugation is there, a resonance is there. So, that is the trick you can apply to understand. And next is the molecule will be a planar molecule if conjugation is there. Alright. Now, we understood that we can figure out whether resonance is there or not through conjugation, whatever I explained it to you over here. In short, I can say you have double bond, single bond, on the third atom if you have lone pair or plus or minus or free radical or double, any of these if you have, that means conjugated system we have and resonance will be there for sure. So this is a trick I told you that will help you to understand whether resonance is present or not. If resonance is there, stability is there. If resonance is not there, it is less stable. Alright, next we have few pointers which will help us understand which resonating structure or which contributing structure is more stable. So if a resonating structure is neutral, it is always most stable resonating structure. So neutral resonating structure, maximum stability. Next, second point is a resonating structure in which octet is complete, that will be more stable. For example, if I have something like this CH3 sulfur, then you have CH2 plus. We have this first resonating structure. I take another resonating structure something like this CH3 sulfur, and you have double bond CH2 plus. Now if you see, this carbon has incomplete octet, and here each atom has complete octet, So a resonating structure in which all atoms have complete octet will always be more stable in comparison to a structure where incomplete octet is present. So out of these two, the second structure is more stable because complete octet, that means 8 valence electrons are present on each atom. Alright, so 8 valence, that means octet is complete. Here you have at carbocation we have 6 valence electron, so incomplete octet. Here you have 8 valence electrons, so complete octet. So second point was, first was neutral resonating structure, maximum stable. Next, if neutral is not present, then you see complete octet. If complete octet resonating structure is present, it is more stable. Next you move on, you see if number of covalent bonds is more, the resonating structure will be more. And thirdly, we see if opposite charges are present, they should be nearby, and if same charges are present, they should be far away for greater stability, and negative charge should be present on a more electronegative atom and positive charge should be present on less electronegative atom. That resonating structure will be more stable. So I have discussed all the pointers which you need to keep in mind for finding out which resonating structure is more stable and which is less stable. I hope it will be very helpful for you. Thank you so much. Bye.